In this video we're going to be talking about matrices, doing a little bit of an introduction to them, and then how to add and subtract them as well. A matrix, its simplest definition, is simply an arrangement of numbers in rows and columns. That truly is all a matrix is. The plural is matrices. So one singular is a matrix, and then if you have multiples of them, they are matrices. That is the plural of it. Okay? One thing you will be asked to do with matrices is to find their dimensions. When you give the dimensions of a matrix, you always want to give the rows first and the columns second. Meaning, for example, here is just a random matrix. These numbers are completely made up. There's no significance to them or anything like that. I'm just giving a random example of a matrix. So if you have a matrix that looks like this, understand that rows are side to side. Rows are side to side. Terrible arrow there. And columns are up and down. Okay, rows are side to side, columns are up and down. So we have one row, two rows. We have one column, two columns, three columns. Meaning if we were giving the dimensions of this matrix, it would be a 2 by 3. 2 rows by 3 columns. Okay? Row by column. 2 by 3. There is no limit to how many rows you can have, no limit to how many columns you can have. Matrix can be as large or as small as you can imagine. Now let's say you want to add or subtract two matrices together. It's actually pretty simple. If you want to add or subtract matrices, all you do is just combine corresponding entries, meaning the numbers that are in the same spot with each matrix. Now for that to work, you kind of have to have corresponding entries, which would mean if you're going to add or subtract two matrices, they have to have exactly the same dimensions. You have to have exactly the same dimensions to be able to add or subtract matrices. So for example, as you see here, we've got two matrices. Our first one is a 2 by 2 matrix of 7, 8, 0, 1. Our second matrix is also 2 by 2 of -4, 2, 3, -2. So because these are both the same dimensions, that means we will be able to add or subtract them. In this case, we are going to be subtracting. So the idea is my top left, my first entry in my first matrix is 7. My first entry in my second matrix is -4. So if I want to subtract these two matrices, my answer is going to be another 2 by 2 matrix, and the first number in my answer matrix will be the solution from 7 minus -4. Well, if I take 7 minus -4, we know that a double negative is effectively the same thing as a positive, meaning we're really taking 7 plus 4, which would give us 11. And I'd say, okay, well now I want to go to the second entry in each of my matrices, which would be 8 and 2, respectively. So 8 minus 2 would give me 6. And so that will be the second entry in my answer matrix. Hopefully you're kind of seeing the pattern here, but next would be our third entry, which is 0 and 3 in each of these. So we'd be taking 0 minus 3, and 0 minus 3 would give us -3 for the third entry in our answer matrix. Let's find a different color here. And finally, we'd have the fourth term in each of our matrices, which would be 1 minus -2, and that's going to give us the last entry in our answer matrix. 1 minus a -2, same with the first entries, we're taking a minus a negative here. So that's really the same thing as plus, meaning we're really doing 1 plus 2, which would give us 3. So our answer matrix for this subtraction problem is 11, 6, -3, 3. That would be how you add and subtract matrices. Last thing I want to talk about in this video is scalar multiplication, not matrix multiplication, meaning we're not taking two matrices and multiplying them together. That's a separate thing. This is just scalar multiplication. If you're not familiar with the term scalar, it's just a real number basically. It's like a constant. effectively. So when we're saying scalar multiplication, we're talking about you are given one matrix and then asked to multiply that matrix by just a number. Not another matrix, but just a number. Scalar multiplication is effectively just distributive property for matrices, is kind of what you're doing here. Because the idea is you just take the scalar and multiply it to every entry in the matrix. So, like in this example, we are being asked to multiply this 2 by 2 matrix of 2, -5, 3, 1 by our scalar of 4. 4 would be the scalar in this example here. So our answer is simply just going to be taking 4 times every single one of the entries in this matrix. So 4 times 2 is 8. 4 times -5 is -20. 4 times 3 is 12. And 4 times 1 is 4. So that would be our answer for this scalar multiplication problem. It really is just that straightforward.